Alright, so we're going to be simplifying rational expressions, and the first thing I want to do when I'm doing this is look at all of the terms in this fraction, and it goes back to simplifying fractions. When I can reduce fractions, if you remember kind of how to reduce a fraction, it works the same ways in some aspects. For example, if we look at 10, 4, and 6, is there something that they all have in common? So the first thing I'll always do is look at all the parts, all the terms, and see if they have something in common. In this case, every single one of those numbers, 10, 4, and 6, can be divided by 2. And if something goes into every single one of these numbers, what I'm going to do is I'm just going to divide that out, and my new answer will just be the simplified version of that. So I've got 10 divided by 2 over here. That's going to give me 5, and I still have the x. Okay, nothing went. I didn't divide out an x, but 4 divided by 2 gives me 2. So my numerator is now 5x plus 2. So I just divided both of those terms by 2. Same thing on the bottom. Divide that 6 by 2, and this is my simplified answer. It's a lot like when we had, fractions when we just had 8 over 4. You reduce that. 4 goes into both of those, and it would give you 2 over 1. It's the same thing, same principle. I'm just reducing more than one term now. I've got more numbers to factor something out of here. Okay. Now we're also going to have things where they don't all three have something in common. So all three parts, they may not have something in common. For example, I might just have, let's say I had 10x plus 5, and then in my denominator I had something like 2. Those don't all three have something in common. 2 doesn't go into every single one of those terms. And I'll always check for that, but if nothing goes into all three parts, just isolate the numerator or the denominator and see if something goes into just the numerator. So if I'm looking at this, just the numerator, 10x plus 5, does something go into 10 and 5? And yes, it does. I can take out a 5. Both of these are divisible by 5. If I do that, though, if I'm only taking from the top, I'm going to do what we call factoring out what they have in common. These have a GCF in the top of 5, so I'm going to factor that out, and whatever's left over when I divide that will be my answer. 10 divided by 5 over here is going to give me 2, so my answer is going to be 2x, and then 5 divided by 5 is 1. So I've got 2x plus 1. So all I did was I divided both of these by 5. That's what they both had in common, and that's where I got 2x plus 1. Now, I had to include this 5. This is what I factored out because I didn't reduce this whole fraction. I was just dealing with the top of this fraction and looking for a GCF. Okay, now on the bottom, that 2 is not going to change. I didn't do anything to it, so this would be my simplified answer right here. Okay. All right, now when we're dealing with simplifying rational expressions, we also want to look for things that they have in common, and sometimes it could be something like x plus 2. You'll notice that both the top and the bottom of this fraction contain x plus 2. So what would happen is those would cancel out. Okay, and what I'd be left with is whatever's in the numerator, and technically this is x plus 3, and when you divide something by itself, like x plus 2 divided by x plus 2, it gives us 1, because anything divided by itself gives you 1. But my answer would actually just look like this, x plus 3, because dividing by 1 is not going to change that. Okay, so when we're simplifying these rational expressions, we want to look for things that they have in common, and they won't always have something right off the bat that you can easily see. And what I mean by that is you are going to have times where you might have to factor something to see what they have in common, and factoring is going to be something we're going to need to do. We're going to be simplifying these rational expressions. Now, we'd have to use the AC method, and if you've forgotten how to use the AC method, I'm going to leave a link to that video in the description. But I would just factor this numerator. They don't have anything in common. All the parts don't have something in common. So I would just take this and I would factor this using the AC method. And if I do that, I would get b plus 4 and b minus 1. Those are the factors if I use the AC method. And now down here in the bottom, we already had a b plus 4. So once I factored this numerator up here, it shows me what they actually have in common. I couldn't tell because this was in standard form, it wasn't in factored form. But once I factor this, now I can see that they both have b plus 4 in common, and my answer would just be b minus 1. Okay. All right, now here's kind of a little different example where I always look at all the terms here. They don't all have something in common. Nothing goes into all 4 of those terms. But if I look down here in the denominator, I can see that 4x squared and 8x actually have something in common. Something goes into both of those two terms. And in this case, they both have a 4. But when we're looking at those two terms, they can also have a variable in common. And you'll notice that one of those is x squared. I've got 4x squared, and I've got 8x. They at least have one x in common. 4 has 2 x's, x squared, and 8 has 1. I want to figure out what do they have in common. They both have an x. All right, so that's something that I can factor out. Now I'm only taking it from the bottom. I'm factoring out a 4 and an x. I have to include that in my numerator, or in my denominator, sorry. And at 4x squared, if I divide this, 4x squared divided by 4x, the 4's are going to cancel out. One of the x's down here is going to cancel out one of the x's up there, because in the numerator I've got x squared, which is technically x times x. In the bottom, we just have that one x that they had in common. One of those is going to cancel out. So I'm just going to be left with x right there. And now 8 divided by 4 right here, if I divide that out, 8 divided by 4 gives me 2. And these x's just cancel each other out completely. So in my denominator, I've got the 4x that I factored out. This is always going to be, if I'm just taking it out of the bottom, my GCF is going to be included beside what the other factor here. Now in the top of this fraction, I had an x plus 2. So now I can see that these two fractions, or this fraction has something in common. They have an x plus 2 that will cancel out with an x plus 2 over here. So my final answer would be 1 over 4x that I factored out. That did not cancel out. It's still down there. And this would be my final answer. Now you'll notice I do have a 1 in the numerator. My answer is not just 4x, because there's a big difference between 4x divided by 1, where if there's a 1 in the bottom, it's going to cancel out. If I had gotten this as an answer, that 1 would go away and my answer would just be 4x. But if you ever have a 1 in the top, it's going to stay. It's actually going to be included as part of your answer. Okay. Now, so that's it on simplifying rational expressions, just the basic ones. Now we are going to be doing some multiplying. So I want to look at some examples where we're multiplying rational expressions. Now when we think back to multiplying fractions, if you remember how this works, when I'm multiplying, things can cross cancel. For example, this 2 down here would cancel out this 2 up here, and I would just multiply whatever's left over. And technically 2 divided by 2, these are becoming 1s when they cancel out. So they're not like going away and equaling 0, but now I'm just left with the 5 in the top right there. So 5 times 1 gives me the 5, and then 2 times 3 gives me 2. I'm sorry, not 2. 1 times 3 gives me 3. So my numerator would be 5/3, because these 2's canceled out. And all I had left over was the 5 in the top, the 3 in the bottom. And that's how, when we multiply fractions, we're going to be going back to that basic skill. It's just going to be a little more in depth because we're dealing with polynomials. So for example, if I had a fraction and it was x plus 2 times x plus 3, and then in the denominator I had x plus 5, and I multiplied that by something that had an x plus 2 down here in the bottom, and say an x plus 5 here in the top, I would look to see what they have in common and see if anything can cross cancel. So I'm looking across, and you'll notice over here I've got x plus 2, and down here I've got x plus 2. So those would cancel each other out. Now I also have x plus 5 down here in the bottom and x plus 5 up here in the top. Those two things also cancel each other out. My final answer would just be whatever's left over here in the top. If it's in the top, it's just going to be x plus 3. And that would be my simplified answer. All right, and we're also going to see things where I don't see anything that'll cross cancel right off the bat, but I don't want to just multiply. I want to see if something can be factored. If I see an x squared, chances are I'm going to be factoring this. So I would factor this. I would use the AC method. You know, again, with the AC method, it's factors of AC, which are -8, that add to +2. Whatever those factors would be, you know, factors of 8 would be 4 and 2. I would just need to make sure that I make the 2 negative because I'm trying to add numbers that give me +2 but multiply numbers that give me -8. And these are my two factors. If I'm using the AC method, they multiply to -8, they add to +2. So I have factored this. Now my factors become, since that's a +4, x plus 4. And now I've got x minus 2. Okay, and in the bottom I didn't do anything with that. It's still a 5, but that's going to help me simplify these because if you look back, I was multiplying 1 over x plus 4 by what I just now factored. I factored and I got x plus 4 over x minus 2, or times x minus 2 over 5. Okay, so now when you look at these, you can see that this one has an x plus 4, this one has an x plus 4. Those will cross cancel, and my answer will be whatever's left. And I've got x minus 2 on the top. That's the only thing that's left in the top. And in the bottom, the only thing left was 5. So that would be my simplified answer. Sometimes we do have to factor before we can simplify. Okay. Now, when you get into dividing, dividing is essentially multiplying. Yeah, this is going to go back to dividing by a fraction. And we used to say that this was keep it, change it, flip it. In other words, keep this first fraction exactly how it is. It's just going to stay p minus 1 over 7p. Alright, so I'm just going to keep the first one how it was. I'm going to change this to multiply though. It was a divide. I'm just going to change it to multiply. And I'm going to flip this fraction here. So whatever's in the top, p minus 1, is going to go to the bottom. And whatever was in the bottom is going to go up to the top. So I had 7p squared plus 35p. And now it just becomes multiplying. Okay, so if you see a division, just keep the first fraction, change it to multiply, and flip the other fraction, and we'll do the same process. I would start looking to simplify this, look for a GCF, and then the process would continue. You know, and here right off the bat, I can already see that something cancels out. But if you see division, just keep it, change it, flip it, and it becomes multiplying, and everything's the same.